This is a tutorial on how to do triangulation for a space unit. I'm making this video to help my science students understand this concept and to give them something to refer back to whenever they need to. If there's anybody else that this helps as well, that would be great. So essentially, there are two parts to this problem. The first part happens in the field. It doesn't matter if you're doing this to measure the distance of um, some object in space. Okay. In that case, you would use an astronomical tool to help measure the angles of that object and using the associated parallax that comes with it. Or we can do this to solve the classic tree across the river problem, which is what I'm going to show for you later. The second part is taking that information that you collected in the field and you draw a diagram to scale on your paper using the exact same angle measurements that you took when you measured things out in the field. When you combine this information, you should be able to use geometry to figure out how far away that object is from the baseline. Here's just a quick overview of the steps to follow to solve the triangulation problem. First step, you need to measure the distance between the two observers out in the field. Each observer will have a different point of view of the object of interest, so they have to take the angle at which they see it separately. So you're going to have two different angles, angle from observer A and an angle from observer B. At this point, after you have the baseline distance between the two observers, as well as their respective angles, you're now ready to draw a scale diagram. In order to do this, you have to use a protractor and a ruler, otherwise the procedure will not work. You have to maintain the exact same angles that you observed in the field on your scale drawing. Using your scale, measure the distance that the object is from the baseline and calculate the distance of the object using your scale. We'll go ahead. This is an image that represents what we are measuring in the field. We have two observers at point A and point B. They want to measure how far the tree is from their baseline. But there's a problem. In this problem, there is a river that is between them and the tree. So they do not have direct access to measure the tree. So they have to use the method of triangulation. And this is why this is a very good example to teach and demonstrate the method of triangulation, which can be used to measure the the distance of cosmic objects using geometry. So the first step that is involved is they measure how far apart they are from each other. In this example, they measured a distance of 24 meters. The longer the baseline, the more accurate your procedure will be. And then what they do is they measure the angles at which they can see or which they can observe the object. In this case, they found that the first angle for person number 1 is 35 degrees. So this here is 35 degrees. And the second angle they found the angle to be 25 degrees, just using a protractor, for example. I did this separately and took a picture. I hope that is clear enough for you to see. I will try highlighting some things as we go on. In the upper right hand corner, as you can see over here, I have the data collected. So all I did is I just rewrote the data so I don't have to go back and refer to that diagram. So the baseline distance is 24 meters. Angle 1 from the first observer to the tree is 35 degrees. Angle 2 from the second observer to the tree is 25 degrees. And I chose the scale to represent. So 1 centimeter that I draw represents 2 meters out in the field. The scale that you choose, it doesn't really matter as long as it's practical. For example, a scale of 1 centimeter equals 1 centimeter drawn equals 1 centimeter or 1 meter in real life wouldn't work in my case because my page isn't wide enough and I did not choose to turn the page on its side. So that would not be a good scale. So I chose 1 centimeter is equal to 2 meters. After that, you need to draw a baseline from point A to point B, which I did right here, and I did that using a ruler. Measure it according to your scale. In this case, since my scale is 1 centimeter drawn is equal to 2 meters in the field, I drew a line that is 12 centimeters long. Okay, so my line is 12 centimeters long. Okay, so my baseline on my scale diagram is 12 centimeters long. Okay, and that corresponds nicely to the 24-meter line observed in the field. After that, I take a protractor and then I carefully measure the angles from the field. Now notice here, okay, notice here and here that it's 35 degrees and 25 degrees. This is the key to doing these problems correctly. I cannot measure out 24 meters on my sheet of paper, but I can maintain the angle. So these angles are always going to be the exact same angles that you measure out in the field, and they're not going to change. They're exactly the same. As I said, this is why triangulation works. Afterwards, you're going to draw lines from each point at each angle very carefully so that they are long enough and they intersect at this point here. Okay, at this point here they need to intersect. The intersection point corresponds to where the object is located. In other words, this is where our tree is. Oops, sorry, this is where our tree is. We find that right there. Using a ruler, draw a line from the point of intersection to the baseline. Measure the distance and use the scale to get the actual distance of the object as is shown here. So what I did is I just took a ruler and I measured the distance from the intersection, the point of intersection, to the baseline. Now, looking back at this, I probably shouldn't have used A and B because I used A and B here in when I explained what happens in the field, but that's okay. So when I did it, I measured it to be 3.4 centimeters. I'll rewrite that in case you can't see it very well. 3.4 centimeters. The next step I did is I just used my scale and I did some simple algebra to calculate what the distance of the tree would be on the field using my scale. So this is 3.4 centimeters. I took that number, multiplied it by 2, did some algebra, and then I find that the distance is 6.8 meters. Okay, so back to this one. So if I just kind of click through this again, okay, and then all I did was just redrew the line there, and the distance is 6.8 meters. Okay, this is the same technique as I said earlier, used to measure the distance of celestial bodies in space, coupled with the effect of parallax that we talked about in class. I really hope this helps, and thanks for watching.